The last topic in this very short unit is calculating error in measurement. It's a concept that's very similar to figuring out the percentage change. What we're talking about is what's the amount percent that we are off when we are comparing the actual measurements of something to the measured amount, which may be off a little bit because you're doing something by hand that may not be 100% accurate. So our two concepts are absolute error. And absolute error is the actual minus measured, or AM. Okay? That's a way to think of it. AE, AM. And it's inside the absolute value brackets, because then that means whatever value we come up with is going to be a positive number. Relative error, and in math, the word relative means it's like a ratio concept that we're doing. So relative error is that absolute error divided by the actual, or so we go A, M, A. Okay? So that we will get a decimal or a percent. So we have the measured length of a segment is 4.13 in actual. What is the absolute and relative error rounded to the thousandth? So the absolute would just simply be actual minus the measured, or 0.02 centimeters. And then the relative would be 0.02. And again, the key here is that you're using the actual 4.15 to get 0.005. Okay. Now, in the example below, we're measuring a turf football field, and we have actual and measured amounts. And we want to know the relative error in measurement for the area of the football field, because he's replacing the turf. So my actual is 120 by 54, or 6480 yards squared. My measured is 103 times 60, which is 6180 yards squared. So my relative error is the actual of 6480 minus the measured. Divide that by the actual, and I get 0.046. You don't label the relative error because it's just giving you a percentage. All right, now the next concept, and if you follow through the math here, it's not as crazy as it may sound. But what we're trying to do is to figure out what our the greatest amount that we can be off if we don't have actual measurements. And what we're talking about is, suppose we're measuring something with a ruler or yardstick or tape measure, and we want to know how far we can be off from on our measurements. Okay? If you follow my steps, it actually isn't so bad. All right? What we want to do is find the area or the volume, whatever it is you're talking about. The greatest possible error is half of the smallest unit of measure. So in other words, if I'm measuring something in inches, then half an inch is the farthest I can be off. That's the greatest amount I can be off because of how my rounding works. All right? Then I'm going to find a new area or volume, and then find the relative. All right? So let's go through this. Excuse me. My measured amount is 19 by 4, which is 217.28 centimeters squared. Okay? The farthest, or the greatest possible error, is half of 0.01, because that's the smallest unit of measure that I have. That's how accurate I am to. So now what I want to do is figure out the area with error in it. So in other words, I'm going to redo the first computation, factoring in the how far off I can be. So in other words, 19.400 or 405, sorry, by 11.205, so that it's 217.43, okay, centimeters squared. All right. Now, what I'm going to do is go back and figure out what my computation is, all right, with based upon that. So in other words, this becomes like my actual, this becomes like my measured. So I'm taking the absolute value of 217.28 minus 217.43 and dividing that by 2.17.28, and I get my numbers are correct. Let me just double check here because the rounding is, numbers are pretty small. Just bear with me for a second. So I'm just grabbing a calculator to check my. Wish I had a pause button on this thing so you don't. Okay. And yeah, it was. I did have it correct. Comes out to 0.1237. Okay. All right. So let's just do the next example. Where I have a rectangular prism and I'm dealing with the relative error and how far off I can be for volume. So again, my measured volume is 5 by 4 by 2, which is 40 feet cubed. My greatest possible error is half of 0.06 or 0.03. So now I'm going to get my volume with error. So it's going to be 5.03 times 4.03 times 2.03, which is 41.15 feet cubed. And then now I go and do my computation. 40 minus 41.15 divided by the 40, and that gives me 0.029. Okay, so again, just to recap, what we did today was computations of relative error in measurement.